Hey guys, it's Miss Fifield. I am here to work with you on week 6, days 4 and 5 together. It's if you've looked at the packet, you've seen that it's like a combined kind of activity, and it's really up to you how you want to do this. So if you want to do all 4 of the activities today, you could do them all together. You can spread it out over Thursday and Friday, but this is 2 days worth of packet work all in one video because it kind of goes together. It's nighttime. You can see it's really dark because I was at Tubman all day today cleaning out our classroom, and I'm going to be back there again tomorrow. So I'm making my video tonight for you to have ready for you tomorrow on Thursday. But I'll be back at Tubman, so I can't make it tomorrow. So I'm just doing it at nighttime. Let's go ahead and let's get started. You should hopefully either have your packet or a pencil and paper out in front of you already so that you are ready to go. These examples in these activities look a little different than what we're used to, and it's just kind of a different way to make sure we know what's going on with fractions and kind of how to use it differently than we've been seeing it in our packet. So activity 1, how far did she go? For each number line shown below, tell how far Nicole went. Explain how you know. Like we always do, we always want to look at our endpoints first. So you see here, our endpoints are 0 and 1, our whole numbers. And then we have some lines in between. But obviously this space is not all the same, right? This and this are about the same, but this space here is much bigger. We know that fractions mean equal parts. So almost like our brains and our eyes already tell us that there's something missing. There's another line that we have to add, right? We have to add a little line right here to make these all the same. And your brain might have already just kind of like done that for you. If your brain didn't just kind of pop up and see that spot, like, I need to put a line there. You can use like your fingers or your pencil to kind of like estimate to see how big each piece is, like that. And your brain will kind of like help you to see like where a line may be missing. Or you can measure with a ruler if you have one, or even just like your fingers, like I said. But now we have these nice even spaces, and now we can figure out what our units are because we have all of the equal parts together. Nothing's missing. So we have 1, 2, 3, 4 parts equal to 1 whole. So we know those are fourths. And right here, we're talking about just that first one. So the first distance is 1/4. You can label it next to it. You can label all of these on here if it's helpful for you, but your answer, the most important part that they're looking for, is to make sure that you see that that's 1/4. The second one below, there's obviously some spaces missing too. So if you see the size of like this and this are the same, these are not. So your brain might have noticed, or if you've measured it, like we've got to put a little line here and another one here. And now we can see all the lines are like equally spaced out. And then we can count to see what the units are here. So we've got 1, 2, 3, 4, 5, 6. Those are sixths because there are 6 parts equal to 1 whole. And we're pointing to this one. So this would be, we know 0/6, right? 1/6, 2/6, 3/6, 4/6, 5/6. So this distance here is 5/6. If it's helpful, oopsie, that is supposed to be a 6. I don't know what that is. If it's helpful, you can label all of them, but it's very important to make sure if you do that to circle your answer so that looking back, you know what you were talking about. Okay, so if you labeled all of them, that's great. Circle your answer. All right, activity 2. Locate 1, like 1 whole on the number line. Label the point and be exact as possible. We have 0 as our first endpoint, and this is 1/4 here. Now we need to continue counting by fourths and make those spaces as equal as possible. Like each part has to be as close to the same as we can possibly do it. And we know how many fourths are equal to 1 whole, 4 fourths. So we'll go, we want to make the next one like the same exact space if we can. So like here it would be 2/4. Here would be 3/4. So here would be 4/4 or 1/2. I'm gonna write it both ways. I'll write 4/4 below, and I'll do 1/2 at the top. It might feel like just really obvious to do like 0 and 1 as the endpoints, but it's not actually all the way over here. We could probably even fit 5/4 here. So they're wanting to make sure that you know that each piece has to be the same size, as close to as we can possibly make it. So here's our 1/2 or 4/4. We know that those are equivalent fractions. All right, same thing here. Locate 1 on the number line. Label the point and be as exact as possible. I've got 0 here and I have 5/3. 5/3, that numerator is greater than my denominator, so I know that's a fraction greater than 1/2. That means 1/2 has to be this way, somewhere over here. So this is 5/3. We need 4/3, 3/3, 2/3, and 1/3. We need 4 lines in here. So we want to be able to make those like as close to the same as possible. And you're doing this hopefully with pencil on your paper. So if you make a mistake, you can come back and fix it. And I can do the same because I can just erase what I've done. But those look pretty close to the same, right? They're all right. So 0/3, 1/3, 2/3, 3/3, 4/3, 5/3. Which one of those is equivalent to 1/2? 3/3. So that is the one we're going to label, circle, whatever you need to do. We can do 1/2 above it like that, but it's important that we have that as close to exactly where it is supposed to be as we possibly can. So right about there. Activity 3. This time we're going to find 2/3 on this number line. Label the point where 2/3 belongs on the number line. Be as exact as possible. Well, this shows us 1/4, not thirds. We know thirds and fourths are different. There are a few different strategies to visualize where this should go. The first thing I want us to be thinking about is the relationship between 1/3 and 1/4 and which one would be bigger. If we have fourths, we're partitioning the whole into 4 parts to share. If we're partitioning into thirds, there's only 3 parts. Each piece would be bigger. So 1/3 is going to be bigger than 1/4, and that's something that hopefully we can visualize in our minds from the work that we've been doing. Let's also think about where 1/2 would be. It's really helpful to find other numbers when we can have both endpoints. So let's find 1/2. If this is 1/4, 2/4 would be here, 3/4 would be here, and 4/4 would be here, 1/2, right? Now I'm going to do something crazy. Okay, it's going to feel like it's not what we're used to doing, but I'm actually going to erase these 2 lines I just made. Those just helped me to figure out exactly where 1/2 would be, but I don't want them to confuse us. So I'm going to erase mine, and I want you to erase your 2/4 and 3/4 lines. Okay? Now, I want you to pretend that you can't even see this at this point, and I just want you to look at 0 and 1. Okay? Now we need to partition this into 3 equal parts so that we can find 2/3. So I want you to visualize and remember what I said about 1/3 being bigger than 1/4. And I'm going to say it's about right there and right there. So from 0 to here is 1/3. And this is 2/3. And we know that 3/3 and 1/2 would be equivalent. And those are about the same. This probably should be over a little bit more. But we're able to, let's see, there, that's better. That 1/3 is going to be a bigger piece, a bigger unit fraction than 1/4 would be. And then that same distance from here to there is about what we should have from 1 to 2/3. So, and then you can circle that because that is your answer for this activity. Last one. The missing endpoint. So we have a mystery endpoint here, and then our other endpoint is 9/6. We know that's a fraction greater than 1 for 2 reasons. Because 9, our numerator, is greater than our denominator of 6. Also because 1/2 is right here, and we know anything over here is bigger. So we're going to work with the unit sixths because that's what we've got down here for this endpoint. This is 9/6. How many sixths are equivalent to 1/2? Hopefully you said 6/6. So we're going to write that here. Okay, so we're going to do the things we know first. Now, we have 6/6 here, not our endpoint, but in this other spot that was given to us. And we have 9/6 over here. How many sixths are between 6/6 and 9/6? There's 3 parts, right? And that's going to mean we need 2 lines to decompose that or partition that into 3 parts. So we already have 6/6. We need 7/6 and 8/6. So I'm going to, right here, be about 7/6. And then right there is 8/6. And then we have 9/6 here. I'm noticing that each of these parts is about the same as this distance here. So I can look and go backwards, right? Because I have everything from this end over. So I have 9/6, 8/6, 7/6, 6/6. What would come right before that? 5/6. This is a little tricky because we're not used to seeing fractions on our endpoints. We're really used to seeing whole numbers, and our whole number is right here in the middle instead of on the ends. So this looks really different than you're used to. So if this was tricky and confusing for you, that's okay, because this is just not something that we've done very much. This is just kind of a quick activity to see how we are doing. If it was difficult for you, that's okay, but just keep in mind that that means we still have a lot of work to do with fractions, and you can do that on both ST Math and Zern. I can see that a lot of you are getting on, and that's great, and keep it up. Those of you who haven't been getting on as much, today and tomorrow are great times to do that, because that was a pretty quick, easy packet activity for you to do, and now you have probably lots of time and no second lesson to do tomorrow, Friday. So definitely log into Zern and log into ST Math and continue working hard, and yeah, just keep it up, and we will see you soon. All right, bye.